This is the final presentation of the CS800 special topic course on procedurally generated music. As part of this course, a music web application has been created that generates music using a combination of the following approaches: Markov imitation, scale transformation, genetic algorithm. In the previous video presentation, we had looked at how the Markov imitation and scale transformation options were implemented. So in this presentation, we will instead focus on the genetic algorithm component. When using a genetic algorithm to evolve an aesthetically pleasing piece of music, one has to deal with four important procedures. Encoding, which is essentially about how one represents a piece of music as a sequence of numbers in a linear construct such as an array. And then there is the task of generating variations of the encoded music so that one has a pool from which musical pieces can be selected from. Which musical piece will be selected depends on how we assign fitness based on a particular pattern of notes. We also look at how the algorithm actually implements selection. The encoding of a musical piece is straightforward because the music itself is nothing more than a sequence of notes arranged linearly. And this can be represented in a linear array by using numbers to represent pitch and note duration, as shown on this slide. Now that we have our digital genome, how do we generate variation for selection to work its magic? There are three methods available: point mutation, recombination, transposon propagation. Point mutation involves selecting a single node at a random position on the chromosome and changing it to some other random node value. Recombination requires a pair of chromosomes. We usually use the top 25% of our digital genome population for this. A random crossover point is selected and the sequences beyond the crossover point are swapped as shown on the slide. Transposon propagation is used by nature to more efficiently create order at multiple length scales, something which cannot be quite easily achieved with the previous two methods. We copy nature and implement a method for copying genetic information from one location of the digital genome to another on the same chromosome. The key to the success of a genetic algorithm, one that allows it to create melody that sounds like real music, is a fitness function. The slide is self-explanatory, so we will move on to consider how the selection mechanism is implemented in code. This slide shows the heart of the genetic algorithm. In the app, we have used a population size of 500, and the population of genomes has been allowed to evolve for 500 generations before the genome with the highest fitness score is selected and used to generate the music that the app plays. Now on to the actual demonstration. The latest version of the CS800 music app has a genetic algorithm option, and in this video I'm going to show you how it works. When you first start the program, the genetic algorithm option is not switched on by default. You will have to manually select one of the available options. Let's say we want to use the genetic algorithm option to create a music or piece of music that is the same musical features as Nella Fantasia. So we will select this option and then we will just play a few notes on the keyboard. The notes that you play will not directly influence the tune that will come out of the genetic algorithm. However, it will seed the algorithm so that it starts its search at a particular point in the genome space. Okay, since the record button has already been armed, let's just play a couple of notes. And we press stop, and the genetic algorithm option kicks in, and this is going to take some time because this is a very old computer, a 10-year-old computer. On your computer, if it's one of the more recent ones, it will probably take less than a minute to evolve a suitable piece of music. I'm just going to fast forward this so that we get to the end result. Now that the genetic algorithm has finished its work, let's press play and have a listen to the music that the genetic algorithm has created. You'll notice that in addition to the main melody line, the genetic algorithm has computed the most appropriate chord sequence played here by the piano keys on the lower register. Now you might be thinking that doesn't sound really like Nella Fantasia. However, the goal of the genetic algorithm is not to create something that sounds exactly like Nella Fantasia, only to create a piece of music that shares the same musical features such as pitch intervals, note duration intervals, and so on. The chord accompaniment is not played if you were to combine the output of the genetic algorithm with one of the Markov imitation options. So if you want the chord accompaniment to play, do not combine the genetic algorithm option with either the first order, second order, or third order Markov imitation. You can, however, use the scale transformation option if you wish.